We're now going to learn about a new unit called matrices, or if we're talking about singular, matrix. And a matrix is basically a set of a bunch of numbers, and you read them by rows, which go down, and columns, which go to the side. The dimensions of a matrix are your rows by your columns. We always put the row first. And we do that with little subscripts, so M subscript ij means the element that's in row I and column j, so it's always row first. Today what we're going to look at is basics like that, naming certain elements, and then adding, subtracting, and multiplying by a scalar. So to add and subtract, you add or subtract the corresponding elements. So where I have the little stars, those would be the corresponding elements, so I would add or subtract those two things based on whatever operation I have. If I want to multiply by a scalar, so for us, a scalar just means a normal number versus the next video we'll talk about multiplying two matrices together. So when I multiply matrices by a scalar, you multiply each element by the scalar. So basically you could kind of think of it like distribution. So what does this look like in some problems? So the first thing we want to talk about is dimensions. So dimensions means your row by your column, not times, it means by. So the A would be it's 2 rows by 2 columns. B is 2 rows by 3 columns. C is 2 rows by 3 columns, and D is 2 rows by 2 columns. Now we're going to do some operations. So the first one says negative D. What that means is I'm going to multiply everything in D by, you guessed it, negative 1, which is effectively going to change all my signs. So when I distribute the negative 1 to everything, it's going to switch my signs. So I have negative 4, negative 17, 1, and 0. Next we want to add A and B. What do you notice about A and B in terms of their size? They don't have the same dimensions, so I can't add them. So to add and subtract, your dimensions need to be the same. So what if instead we wanted to do B minus C? I can do B minus C because they both are 2 by 3 matrices. So order matters with subtraction. So make sure you have B, matrix B going first. Minus and I'm going to set up the next one just so I can see what I'm doing easily for the next part. So we're going to be multiplying B by 3 and then multiplying C by 2 and adding those answers. All right, so let's actually perform those operations. So let's start with B minus C. So we're going to subtract the corresponding elements. So 3 minus -1 would be 4. Then 5 minus 4 would be 1. 9 minus 7 would be 2. -2 minus 15 would be -17. 3 minus 3 is 0. And 4 minus 8 would be -4. For the next problem, the first thing we need to do is multiply by our scalars. So when I multiply 3 into these, I get 9, 15, 27, -6, 9, and 12. Plus, multiply everything by 2, -2, 8, 14, 30, 6, and 16. And now we add those together by adding the corresponding elements. So 9 minus 2 is 7. 15 plus 8 is 23. 27 plus 14 is 41. -6 plus 30 is 24. 9 plus 6 is 15. 12 plus 16 is 28. So when I look at 2AB, or 2A minus 3B, I also am not going to be able to combine those. Once again, we're not going to have the same dimension. But I could do the next one. I could do D minus A. So D is 4, -1, 17, 0. A is 7, 2, 3, 1. So 4 minus 7 is -3. -1 minus 2 is -3. 17 minus 3 is 14. And 0 minus 1 is -1. On this screen, I want you to pause and try these problems on your own, then check your answers when you're ready. Let me know if you have any questions.